In this lesson, we are talking about arithmetic sequences. Arithmetic sequences is just a list of numbers that follow a specific pattern. So each number in the list is a set amount more or less than the previous number, and that pattern is created by adding or subtracting a certain amount between each number in the list. So first we'll just do some vocabulary. So the first number in the list is A1. So A sub 1, that little subscript of 1 tells you your place in line. So that's the first term. And let's say I give you the first term is 2. All right, then the second number in the list, A sub 2, the 2 tells us that we're second in line. And let's say I give you a 6 for that number. Then let's say we have 10, 14, and 18. All right, well, just kind of to continue with some of this vocabulary, we have the first term, A sub 1, second term, A sub 2, third, A sub 3, A sub 4, A sub 5, and then you have A sub n is the nth term. A sub n can be any number in line. Then the number just before that, so if this is A sub n here on the end, then the number just before it would be A sub n minus 1 because it would be the previous number. In this list that I've given you, there is a pattern between each number. So from 2 to 6, if we're adding or subtracting, we would be adding 4. 6 to 10, and so on. So that number that you're adding or subtracting is called the common difference, or the D value. So D, in this case, is 4. Let's look at a real-world example of where a sequence might occur. Evie is saving money to buy a new toy. She already has $12 in her account, and she earns an additional $3 per week in allowance to help save up for the toy. Fill in the table to show how much money Evie has in her account after n weeks of saving. So n represents the number of weeks in this table. And A of n would represent the amount of money that she has. So in this table, we can see that after 1 week, she has $15. After 2 weeks, she has $18. So what was the difference there? It was an addition of $3. So in the third week, she would have $21, and we would find that by adding 3. And then we would add 3 again. And in the fourth week, she would have $24. If we did that one more time, in the fifth week, she would have $27. So based on this table and the context of this problem, what type of function does this remind you of? We have a common difference or a common change in values, and we started out with a certain amount. To me, that sounds a lot like a linear function. So you'll see that arithmetic sequences are a lot like linear functions. All right, in part B, it says to write a recursive definition for the sequence. So a recursive definition or a recursive formula is just a way of describing what you start with and then how you add or subtract to get the next terms in the list. So a recursive definition always starts with giving you A sub 1, or the first term. In this case, A sub 1 is 15, or A sub 1 is equal to 15, because that's the first term, or when n equals 1. Then every term after that, A sub n, is always the previous term which is a sub n minus 1, plus the common difference, which was 3. So again, any term in the list is the previous term plus 3 in this case. So that's our recursive definition. Sometimes you'll see them in brackets like this. In part C, it says Evie suggests the following explicit formula, which is more like a function, to define the amount of savings, which is A, in terms of the number of weeks in that she has saved. Is this formula correct? Let's test it. So a recursive formula tells you the first value and then how to get the next value based on the one before it, and then you add the common difference. An explicit formula tells you the first term as well. It tells you the common difference, and then we'll deal with this part later, the times n minus 1. We'll see how we get that, but let's first test this explicit formula that Evie came up with and see if it's correct. So remember that a sub n is the amount of money she had after n number of weeks, where n is the number of weeks. So is it true that after 1 week, let's see how much money she had. If we plug in n equals 1. So if n is 1, that would mean that her amount after 1 week is equal to 3 times 1 plus 15. So you can see how this resembles function notation. So is it true that a of 1, or the amount she had after 1 week, which was 15, is that equal to 3 plus 15, which is 18? No. So this is not the correct definition. For example 2, an arithmetic sequence is given using the recursive definition that follows. In this recursive definition, the first term is -3, so b sub 1 is -3. And then the recursive definition tells us that every term after that is the previous term plus 6. So b sub 2 is b sub 1 plus 6. So b sub 2 is b sub 1 plus 6, which gives us 3. Then b sub 3 is b sub 2 plus 6, which gives us 9. And we'll continue that pattern of plus 6. So b sub 4 ends up being 15. In example 3, for each of the following sequences, determine if it is arithmetic based on the information given. If it is, fill in the missing blank, and if it's not, show why. So if it's arithmetic, remember that that means that you have a common difference. Okay, so by adding or subtracting, how would I get from 5 to 9? That would be plus 4. 9 to 13 would be plus 4. 21 to 25 would be plus 4. So this is arithmetic because there is a common difference. Right, so if the common difference is 4, we can fill in that blank. 13 plus 4 is 17. 17 plus 4 is 21. So that's just a way of checking yourself. In part B, from 7 to 4, notice this is decreasing, so we're going to be subtracting 3. 4 to 1 is -3. -5 to -8 is -3. So yes, so we can use that to get from 1 to the next number. So 1 minus 3 is -2, and just to check, -2 minus 3 is -5. In part C, let's look at this one. So 5 to 10, if I were adding or subtracting, I would have to add 5. From 10 to 20, I would have to add 10. 20 to 40, I would have to add 20. So this is not a common difference. And since this is not a common difference, It is not an arithmetic sequence. All right, let's try D. From 64 to 16, that would be subtracting 48. If you're ever confused on how to get that number, if it's big numbers like this, the common difference, that term comes from saying 16 minus 64, which is negative 48. And then if you wanted to see from 16 to 4, you would do 4 minus 16, which is negative 12. So since this is not a common difference, this is not arithmetic. Example 4 is where we're going to learn how to create that explicit formula that we mentioned at the very beginning. So let's see if we consider this sequence where the first terms are 4, 14, and 24. Okay, well, if that's the case, then we can just start by looking at those first three, find the common difference, and then find the fourth term. So we have a sub 1, or the first term, is 4. The second term is 14, then 24. So what would that fourth term be? You probably didn't even have to use the common difference. It's 34, because it's pretty easy to see that we're adding 10 each time. All right, well, when we write it out like that, how many times did we add 10 in order to get the fourth term? So in order to find the fourth term, we added that common difference of 10 1, 2, 3 times. So we started with a sub 1, and then we added 10, added 10, added 10, 3 times. So notice the relationship between the term we were looking for and how many times we added that common difference. If this were the nth term, this is n minus 1 times. All right, so let's use that to find the 10th term without counting or without adding 10 so many times. Okay, so remember, if we're looking for the nth term, we're going to add the common difference n minus 1 times. So to find the 10th term, we're going to add that number 9 times. So let's do that. All right, so we're looking for a sub 10. We're looking for the 10th term, and that's going to be equal to, well, we started with 4, and we're going to add 10, which is our common difference, 9 times. So we would add, so we start with 4, and we would add 10 9 times until we landed on a sub 10. So the quicker way of doing that would just be to write this explicit definition, which is 4 plus 10 times 9 is 90, which is 94. Okay, let's write a recursive formula for this. So remember, recursive tells you the first term, and then it tells you to use the previous term and add so much to it each time. So our recursive formula is going to be our a sub 1, our first term, which was 4, and any term after that is going to be the previous one plus 10, because 10 was our common difference. So this is our recursive formula. Now the explicit formula. All right, so the explicit formula comes from what we did in part B. All right, so to find any term, the nth term, a sub n, it's always going to be starting with the first term and adding the common difference so many times. Well, whatever number term you're looking for, so remember when this was 10, we had to add 10 9 times. When this was 4, we had to add 10 3 times. So you're always going to add that common difference n minus 1 times. In example 5, we are going to look at another word problem that's a little more challenging than the first that we looked at. Seats in a small amphitheater follow a pattern where each row has a certain number of seats more than the row in front of it. If the first row has 6 seats and the fourth row has 18, how many seats are in the 20th row? So notice we aren't given row 1, row 2, row 3. So we don't necessarily know what the common difference is right offhand, but we can find it. So the first row has 6 seats. The fourth row has 18, and we want to know what the 20th row has. So what we do know is that this is a pattern where the number of seats is a set number more than the other ones. So we know that there's going to be an arithmetic sequence here. What we don't know is what common difference are we adding 3 times in order to get to 18. So we know that we're starting with 6, and we're going to add that common difference of whatever we're looking for 3 times. And that's going to give us 18. So we start with 6, and we add that common difference 3 times, landing us at 18. That's how we're going to find the common difference. We can just solve this equation, this little 2-step equation, and get d by itself. So subtract 6 on both sides first. That gives us 3d equals 12, and then divide by 3. So d is equal to 4. So our common difference is 4. So we're going to add 4 each time. All right, so row 2 would have 10 seats, row 3 would have 14, and that does land us at 18. So we can check that by just making sure that we are adding 4 and getting the correct numbers each time. Okay, now let's see how many seats would be in row 20. So from what we've learned before, the explicit definition and the recursive definition are 2 different things. First, let's talk about the recursive formula just to get some more practice in. So a sub 1, the first row, had 6 seats. Then every row after that was the previous number of seats plus 4. The explicit definition is what's going to be most helpful in finding the number of seats in the 20th row, because we don't want to add 4 that many times. It would just be time consuming. So what we can say is that for any row, you start with 6 and you add the common difference of 4 n minus 1 times. So if we're looking for row 20, we would do this 19 times. So a sub 20 is 6 plus 4 times 19, which equals 6 plus 76. And that gives you a total of 82. So there are 82 chairs in the last row. All right, let's do just one more example to give you some more practice with this. All right, if a sub 1 is 2 and a sub n is the previous number minus 3, find a sub 12. So first we want to go ahead and get our list going. All right, so if we start with a sub 1 is 2, then our recursive definition tells us that we are taking that number and then subtracting 3 each time. All right, so from this, we can find the explicit definition in order to help us find a sub 12, because this is a sub 1, a sub 2, a sub 3. We don't want to do this 12 times. It's just time consuming. So what we can do is find the explicit definition and just plug in 12. So the explicit formula. All right, so a sub n, so any term is going to be starting with 2, and you're adding that common difference of -3. Now, instead of writing plus -3, I'm just going to write -3 times n minus 1. So if we're looking for a sub 12, we're going to subtract 3 a total of 11 times. So a sub 12 is 2 minus 3, how many times? 12 minus 1 times, or 11 times. All right, so that would be equal to 2 minus 33, or -31.